Welcome to solverfy.
Question was asking to find an expression that gives the values of x for which the signal at the receiver is maximum. Okay, so based on the figure 3553, we'll have such a graph. He said the microwave transmitter is at high A above the water level. Okay, so we said this is the where microwave transmitter located at. Okay, and there's on the other side of the shore, on the opposite side of the shore, there's a receiver which is at a distance x above the water level. Okay, so we say this is x here, and the water level is here, and the distance between the receiver and the microwave transmitter is d. Okay, let's say here's is d. So why don't we make similar triangles based on such figure, and that's how I'm gonna do it. Okay, so I'll create two similar triangles like this. So eventually it will meet at a point like something like that. Okay, let's say these two angles the same, which both of them are theta, and this part is d1. Okay, and this part is d2. d1 plus d2 is equal to d, which is the distance between the microwave transmitter to the receiver. Okay, the length of this part is L1, length of this part is L2, and here this one is the L3. Okay, so the two similar triangle is this one and this one. Okay, well, therefore we can come up with some kind of relationship based on such graph. Well, we know that tangent theta, let me write down, tangent theta in this case can be equal to a over d1, and also can be equal to x over d2. Okay, because this is a right triangle, this is a right triangle here. Okay, and this will give us tangent theta. Let me see, let me rephrase it. Okay, so we know this can give us d1 is equal to a over tangent theta, and d2 is equal to x over tangent theta. Therefore, remember d1 plus d2 is equal to d, so d is equal to d1 plus d2, which is a plus x over tangent theta. Oop. So therefore, tangent theta can be equal to as a plus x over d. Okay, and remember, there's such mathematical equation which is sine theta squared is equal to tangent theta squared over 1 plus tangent theta squared. Okay, so if you study calculus, you'll know what I mean here. you'll be kind of familiar with this equation here. Okay, so this will give us sine theta is just equal to square root of this whole thing, which is tangent theta over square root 1 plus tangent theta, tangent square theta. Okay, so this can give us, remember tangent theta was equal to a plus x over capital D. So a plus x over capital D, and then over square root 1 plus a plus x, the whole thing square, over D square. Okay, and if we move the D on the above the denominator, we'll get a plus x over square root D square plus a plus x squared. Okay, how did it transform from this to the conclusion here? Well, I will show you guys. Let me use a blue pencil. Okay, so we can move D. This can be equal to a plus x over D times D. Since we multiply t above the denominator, that means beneath the denominator need to multiply by d as well. So d times 1 plus a plus x squared over d squared. Okay, so d and d will cancel out, and we can put the d inside of a square root, which will give us a plus x over square root d squared, because square root d squared is d, so in the square root is d squared times 1 plus a plus x squared over d squared. Okay, and this can be equal to I'm sorry, so this can be equal to this. Okay, because if you plug in d squared inside of 1 plus a plus x squared over d squared and d squared will cancel out, and d squared times 1 is d squared. Okay, so sine theta will be equal to a plus x over square root d squared plus a plus x squared. I'm sorry, a plus to the power of a square. So we also know that sine theta can be equal to a over L1, also equal to x over L2. See, a over L1, x over L2. Okay, so this will give us L1 is equal to a over sine theta. L2 is equal to x over sine theta. So L1 plus L2, let's say it's equal to L, okay, which is equal to a plus x over sine theta. and which can be equal to a plus x times inverse of sine theta. And this will give us L, which is L1 plus L2, is simply equal to a plus x times 1 over sine theta is square root d squared plus a plus x to the power of square over a plus x. Okay, so a plus x and a plus x cancel out. So L, which is equal to L1 plus L2, is just equal to square root d squared plus sorry about that. So square root d squared plus a plus x to the power of square. So therefore, this can also be approximately equal to d plus a plus x to the power of square over 2d. Okay, and L3 from the graph can be equal to d plus a minus x to the power of 2 over 2d. And remember, L minus L3 is equal to m plus 1/2 lambda, okay, which is equal to d plus a plus x to the power of square over 2d minus d minus a minus x to the power of square over 2d. This will give us a plus x squared minus a minus x squared over 2d is equal to m plus 1/2 lambda. Okay, and a plus x to the power square minus a minus x to the power square will give us a plus x plus a minus x times a plus x minus a plus x over 2d equal to m plus 1/2 times lambda. Okay, and this whole equation can be equal to 2a times 2x over 2d is equal to m plus 1/2 times lambda. So 2 and 2 here cancel out. We get 2ax over d is equal to m plus 1/2 times lambda. So therefore, x, expression for x can be equal to m plus 1/2 times lambda times d over 2a. If we do a little bit of arrangement here, we'll get d lambda over 2a times m plus 1/2. Okay, and this is the answer for the questions. Thank you.